Thank you to the CLF community for hosting a webinar like this. I know from my personal work that this topic, especially carbon from concrete, is a really big topic right now. We're getting a lot of questions from our clients about it, so it's really exciting to see webinars like this happening. So I'm Kelsey Rose. I'm a senior design engineer at Magnuson Komensick Associates. I've been with the firm for about 7 years now. So for anyone that doesn't know, MKA is a structural and civil engineering firm. We are headquartered in downtown Seattle. So as engineers, we have a pretty great opportunity because we touch so many different projects with so many different developers, and we get to work with a wide variety of architects and contractors and other subs in the industry. We have a kind of a unique position to touch a lot of different things. And so it really makes becoming an environmental steward very important, you know, especially for structural engineers. So even though the topic of concrete and how to reduce its carbon is really broad, in the interest of time, I want to focus on a few select things that I've been seeing happening recently in the industry surrounding carbon reduction for concrete. And those things can be funneled down into design strategies and specification strategies. So I apologize if some of this gets a little bit into the weeds. Kel said that I could get into the weeds, so I'm going to go with that, but hopefully you can bear with me here. But touching on design first, I don't want to get too deep into this because a lot of the things around design are things that your engineer are kind of doing anyways. So that's, you know, optimizing the structure in a lot of ways. You know, the more optimized your structure, the more efficient your structure is, the less material you're going to have in the structure, and then of course you're going to have less carbon footprint. But a couple of things that I want to highlight here is the design criteria, for example, you know, your load path in the building. So the quicker your vertical load can get from one point to where it needs to get down into the building, the more efficient your system is. So for example, your column layout, you know, if you have a high-rise tower that is sitting on a podium and you're trying to get those programming requirements to line up, you're trying to get those columns to thread through from, you know, your upper programming down into maybe a parking level. The more that you can get your columns to align, the less transfers and whatnot that you can take out of the project, the more material that you can also take out and lower your carbon footprint. So it's really going back to basics for some of these strategies, and you know, and reassessing your design criteria from the beginning to make sure that you're looking at it through that lens of reduction. And then another thing to highlight here is reducing concrete strength throughout the height of your building. And that's a really simple thing. A lot of engineers are doing, most engineers are doing that already. So for example, for your columns or for your shear walls, it's maybe having 10,000 PSI concrete at the base because that's where you have most of the load and the demand. And then reducing that maybe to 6,000 as you get to the roof, as the demand drops off throughout the height of the building. You know, just an example of one pretty simple strategy that you could implement. Another thing that we are encouraging designers to look at is multiple design schemes. And so, for example, this is a study that we did recently where we were looking at a typical floor plate for a high-rise tower. And we wanted to look at which concrete strategy would be the most efficient. And for this, we were originally looking at it from a material standpoint. So I know you can't really read this, but up in the upper right-hand corner of each of these schemes is a little takeoff. So it's, you know, how much PT is in here, how much mild reinforcing, what's the concrete volume. So looking at those and trying to find the system with the most material efficiency, or in other words, the least material, right? And so for this one, we chose concrete number 1 because it had the least amount of material. And then recently we retroactively looked at that and found that, oh, what do you know? Of course, if you have less material, you're also going to have less carbon footprint. So it's, you know, looking at these multiple design schemes, which is maybe something that you're already doing on your projects. And that could be because you are looking at different programming requirements that the architect wants to look at, or different scenarios like that. And it's leveraging those design schemes that you're considering already and looking at them through a carbon lens to realize where you might be able to provide some carbon savings. So going out of design and into specification, which they might overlap, but one of the things I wanted to show is the specification language that we are putting out in our specs right now. So we've modified our specifications to include language that requires the submission of EPDs. And that kind of goes back to Dennis's point of earlier of suppliers being out there ready to do it and people needing to ask the question. So this is us trying to ask that question formally. So through EPDs, we are hoping to track the carbon impact of concrete more accurately. And then we're also asking for bill of materials. So we are asking the contractor at the end of the project, or maybe even throughout the construction phases, to submit bill of materials, to submit actual data showing how much material was actually used on the project. So with a more accurate look at the carbon impacts through EPDs, and with a more accurate look at quantities, we can then have a better picture of what the embodied carbon is in our building in that as-built condition. One thing that I wanted to note here, and it's highlighted in the EPD text there, is that MKA is asking for 30, and that's kind of a stance that we've decided to take internally. If you look at the lead credit, the declarations, they give multiple different tiers, I guess, of EPDs you're allowed to submit, and we recognize that. But for us, we've decided that we want product-specific Type 3 EPDs, which means third-party verified too. Another thing that we've started to do with our specifications is moving from the prescriptive traditional way of specifying concrete mixes to this kind of performance method. So in the traditional method, we would tell the GC and the concrete supplier, the test age, the water to cement ratio. But for our prescriptive method, we're trying to strip some of those requirements out. And a lot of that has to do with, we are asking the supplier to come with a mix that meets the performance criteria, rather than us just get statement putting out, you must have this water to cement ratio, for example. So instead, we've been striking out test age, cement ratio, and we've been including exposure class, which is in ACI, and then shrinkage and modular elasticity. So those are the things that we really need for the design to be what we need it to be. But we've taken out some of the other restraints that we had previously had before. And I'll note that the test age is still important for the construction of the project. So for PT slabs, for example, they need to reach high early strength. But since a lot of that falls under the construction needs rather than the design needs, we've started to take the stance that it would be better for us to leave out that requirement, that test age requirement, and leave that to the discretion of general contractor instead. So for example, if the contractor knew that they had a really tight pour schedule and that they needed their PT concrete to reach strength within 24 hours, they're the ones controlling that rather than us trying to take a stab at understanding maybe what the GC is really going to need. So in general, we're hoping that this method, unties the hands of the suppliers and then allows the strength gain to happen over a longer period of time so that they can take some cement out. Because one way to get high early strength is to add more cement to the mixes. And of course, the more cement you have in concrete, the higher the GWP factor in general. So by relaxing that test age, timeline, we're hopefully allowing them to take cement out of the concrete. And a good example of that would be your foundations, where maybe your foundation is built, but you're not actually going to need that strength for months or 6 months, maybe even a year, depending on the construction schedule. Once again, going back to the contractor being maybe better positioned to handle those kinds of requirements. And another thing here, I'm going to kind of put on my construction hard hat here and cross over into something that's not really in the structural engineer's realm, but something that we've been involved with a lot lately, and that's supplier bidding and supplier selection. So overall, the overarching idea is that we are advocating that global warming potential become a consideration during the bidding process. And there are two ways that we've seen, there are multiple ways, but two ways that we've seen this kind of playing out. And I'm going to ask Dave to step in here in a second. And the first way is to include in the supplier bid request the indication that suppliers will need to submit concrete GWP information, and that GWP data will be considered during the award process. So essentially what we're trying to do is compete one supplier against the other by saying, you're both going to have to submit GWP. So, of course you want to get better than your competitor, because that's one of the things we're going to consider during the award process. Another method is to do that, but then also to set a maximum GWP, or to specify a reduction from a baseline that concrete must achieve. And this is where it'd be great to have Dave, maybe you chime in here too, because you and I have had some really great conversations on this topic, and I've been kind of a proponent of the first method, where you don't tell them a max GWP, but could maybe you speak to why you might want to go with the second method?
Yeah, let me start with the first one, if you can go back really quickly. So I think that this can work, and we're using it on some projects. If I, just as Kelsey put on her contractor hat, I'm going to put on my supplier hat. And I think that you need to really be clear about the criteria on which you're going to be selected, because cost is always a criteria, and now GWP is a criteria. And so you need to provide a way for suppliers to not win not provide the best, lowest GWP, but then lose on price. I think that there's some anxiety around that. And so one way to do that is say, provide us your conventional solution, which in many ways is what's tried and true and familiar, but be silent on GWP. And then the other way is to say, in addition to that, provide your solution for each of these applications that is the carbon optimized one. And there you get 2 price points, you get 2 solutions, you give the owner some choice there, you give contractors the choice, right? If it works. So that's one way to address this method. The second method, has, there's sort of a need to, and if I'm understanding what you're doing here, is you are actually providing them sort of the hypothetical values so they understand the proportions of all the mixes in the job. Is that right?
Well, this was one that we had an example that was filled out where we did get information from supplier A and supplier B, and then we were able to compare them, and we were able to go with the one that had the lower, the more reduction. But what this is trying to illustrate is that on top of telling them that they'll be bid, we would also put, within maybe the specifications or the bid language,
okay,
this max GWP that they shall not exceed.
Okay, and I get that. What needs to be here so they understand that is the quantities, so they understand the volumes, because this is going to be very project specific, and I'll actually talk about this in my segment as well.
Great. Okay. Well, with that, I will turn it over then to Dave. Thank you.